A low Earth orbit is an orbit around Earth with an altitude between 160 km and 2,000 km. Objects below approximately 160 km will experience very rapid orbital decay and altitude loss. With the exception of the manned lunar flights of the Apollo program, all human spaceflights have taken place in LEO. The altitude record for a human spaceflight in LEO was Gemini 11 with an apogee of 1,374.1 km. All manned space stations to date, as well as the majority of satellites, have been in LEO. Orbital characteristics: objects in LEO encounter atmospheric drag in the form of gases in the thermosphere or exosphere, depending on orbit height. Objects in LEO orbit Earth between the atmosphere and below the inner Van Allen radiation belt. The altitude is usually not less than 300 km for satellites, as that would be impractical due to atmospheric drag. The orbital velocity needed to maintain a stable low Earth orbit is about 7.8 km per second, but reduces with increased orbital altitude. The delta V needed to achieve low Earth orbit starts around 9.4 km per second. Atmospheric and gravity drag associated with launch typically adds 1.5 2.0 km per second to the delta V launch vehicle required to reach normal LEO orbital velocity of around 7.8 km per second. Equatorial low Earth orbits are a subset of LEO. These orbits, with low inclination to the equator, allow rapid revisit times and have the lowest delta V requirement of any orbit. Orbits with a high inclination angle to equator are usually called polar orbits. Higher orbits include medium Earth orbit, sometimes called intermediate circular orbit, and further above, geostationary orbit. Orbits higher than low orbit can lead to early failure of electronic components due to intense radiation and charge accumulation. Use of LEO. Although the Earth's pull due to gravity in LEO is not much less than on the surface of the Earth, people and objects in orbit experience weightlessness because they are in free fall. A low Earth orbit is simplest and most cost-effective for a satellite placement and provides high bandwidth and low communication time lag. Examples: Earth observation satellites and spy satellites use LEO as they are able to see the surface of the Earth more clearly as they are not so far away. They are also able to traverse the surface of the Earth. A majority of artificial satellites are placed in LEO, making one complete revolution around the Earth in about 90 minutes. The International Space Station is in an LEO about 400 km above the Earth's surface. Since it requires less energy to place a satellite into a LEO and the LEO satellite needs less powerful amplifiers for successful transmission, LEO is still used for many communication applications. Because these LEO orbits are not geostationary, a network of satellites is required to provide continuous coverage. Lower orbits also aid remote sensing satellites because of the added detail that can be gained. Remote sensing satellites can also take advantage of sun-synchronous LEO orbits at an altitude of about 800 km and near polar inclination. ENVISAT is one example of an Earth observation satellite that makes use of this particular type of LEO. Space debris. The LEO environment is becoming congested with space debris due to the frequency of object launches. This has caused growing concern in recent years, since collisions at orbital velocities can easily be dangerous, and even deadly. Collisions can produce even more space debris in the process, creating a domino effect, something known as Kessler Syndrome. The Joint Space Operations Center, part of United States Strategic Command, currently tracks more than 8,500 objects larger than 10 cm in LEO. However, a limited Arecibo observatory study suggested there could be approximately 1 million objects larger than 2 mm, which are too small to be visible from Earth-based observatories. See also: atmospheric re-entry, escape velocity, geostationary, high Earth orbit, highly elliptical orbit, International Space Station, medium Earth orbit, list of orbits, satellite phone, specific orbital energy examples, suborbital spaceflight, notes. References. This article incorporates a public domain material from websites or documents of the National Aeronautics and Space Administration.